function combinations are really easy to understand if you think about just regular numbers that you've known since you were in kindergarten. So let's take the number, for example, 3 and 4. Think about all the things that I could do with 3 and 4. Well, one thing that I could definitely do would be I could add those together. That would give me 7. I could subtract those, which would give me -1. What if I subtracted in the other way? So I do 4 minus 3, that would actually give me 1. So there's two different options. We'll come back to that in a second. I could multiply these two numbers together, which would give me 12. And then I could divide those two numbers, which would give me 0.75. What if I divided it the other way? I would get 1.3. Or again, right, you could make it into fraction 3/4 and 4/3. Okay? So, one thing that I want to start talking about before we actually plug in letters and all of that is whenever I was adding and multiplying, it didn't matter which way I added or which way I multiplied. 4 plus 3, 3 plus 4, it's all 7. Same thing with multiplication. 3 times 4 or 4 times 3, it's just always 12. However, when we were subtracting, the order in which we went definitely mattered. Because if I did 3 minus 4, I got a -1. But if I did 4 minus 1, I got a +1. Same thing with division. If I took 3 divided by 4, I got 3/4 or 0.75. But if I took 4 and divided by 3, then I got 4/3 or 1.3. So when we get to subtraction and division, I have to be real careful that I'm using the same order that they are using with their letters. Okay. Now, anything that I can do with numbers, I could also do with letters. The thing is sometimes we just call them something different. So when we were younger, we called addition just regular addition. But then when we got into probably junior high or high school and we started using variables, we now started calling it combining like terms, which is still adding, right? We're just going to combine them together. So I couldn't put an X with a Y because those are not like terms, but I could still add all the X's and add all the Y's, okay? When we got to subtraction, we had to be careful that we looked at distributing a negative, okay? So we started to call that, instead of subtracting, we're going to distribute the negative. So then we said, well, instead of it being 3 minus 4, we could say 3 plus a -4, right? We got all fancy because we were distributing the negative. Then we could add, okay, right? Like 3 plus that -4. Okay, then we got into multiplication, and we had a couple different words for that. We had distribute. Some of us might know the word FOIL. So there's lots of different things that we could do when we talk about multiplication. But it's still the same thing. I'm going to multiply one value by another. Okay. Then when we got into division, when we were looking at division, probably this was more upper high school, we talked about being able to cancel off common factors. So we could cancel off common factors. And we did this instead of, it's very similar to reducing the fraction, right? So in elementary school, if we had something like 6/4, we would reduce that, right? And we called it reducing the fraction, right? But when we got a little bit higher in math, the reason that we could do that is because 3 times 2 and 2 times 2, and we would cross off the common factor. Okay, so the same thing that we can do with numbers, we can do with variables. Now, they aren't going to use the word, oh, I want you to add these two functions. They're going to use symbols. So I've kind of wrote down all the different types of ways that they could ask. So sometimes, let's just look at the first one. They might say f plus g. Sometimes they might say f of x plus g of x. Sometimes they might say f plus g of x. And this last one normally is the one that gets people, because people will make the mistake and say, okay, I'm going to add them and then I'm going to multiply by x. That is not what it means. If I have an x there, all it means is that in the end, I should have x in my answer. Okay, so it does not mean to multiply. If I look over here and multiply, they're going to use either a closed dot or they're going to use a star. Okay, that's how they're going to represent multiplication. All right, they're not going to use a letter or an X anymore. Okay, so let's look at a couple of examples. The first problem is asking me to add the two functions as f plus g of x. So remember, the x just means that I should still have x's in my answer. It does not mean to multiply by an x in the end. So the first thing I'm going to do is I'm going to take my f function, x squared plus 1. And then I'm going to take my g function, 3x plus 5, and I'm going to add those two together. All right, now since it's just addition, I don't need to do anything with those parentheses. I'm just going to simply combine my like terms, as we said above. So let's start combining those like terms. X squared, there's nothing to combine there. 3x, there's nothing to combine there. But I can combine my 1 and my 5, which would give me 6. And that would be my final answer. So I might not have a single number answer because this has an x in it. Okay, remember that x there at the end. All right, let's look at our next one. This time we're going to take g and we're going to subtract f. So I'm going to start off with my g function this time, 3x plus 5. We're going to subtract x squared plus 1. Right, so remember, with subtraction, we first need to distribute the negative. So I'm going to distribute that negative to my x squared and my 1. So I'm going to have 3x plus 5. Now we have a negative x squared minus 1. And then I'm going to add those together. So combining those like terms, I get negative x squared. There's nothing to combine there. 3x, there's nothing to combine there. I can combine my 5 minus my 1 to give me 4. And that would be my answer. All right, moving on to the next one. This one says f times g. So I'm going to take f, x squared plus 1, and I'm going to multiply it by g, 3x plus 5. So now I'm going to distribute or FOIL, whichever one you want to think of. I'm going to take x squared times 3x would give me 3x cubed. X squared times 5 gives me plus 5x squared. 1 times 3x gives me 3x. 1 times 5 gives me 5. Now remember, anytime I do any kind of distributing or foiling, I need to make sure I can combine any like terms that I have. However, I don't have any like terms here, so this answer is finished. Right? Let's look at our last one. We're going to take g and we're going to divide by f. So I'm going to take g, 3x plus 5, and I'm going to divide by f, x squared plus 1. Now, there's nothing for me to reduce or cancel off here, so that would be my final answer. Okay. So notice on all of these I had an x in the problem. That means I should have x's in my solution. So now let's try somewhere I don't have any x's in the solution. Okay, so looking at this problem, it's different now because I have a 1 here. What that means is I'm going to substitute a 1 in for each x. I'm going to evaluate at it. So if I look at the first one, it says that I'm going to take f, which is x squared, but remember, instead of an x, we're going to use a 1. So I'm going to say 1 squared plus 1. Then I'm going to take g, which would be 3 times 1 plus 5. And I'm going to add those together. So I'm going to do this, remember PEMDAS, I'm going to take the first set of parentheses. So 1 squared plus 1 gives me 2. The second set of parentheses, which gives me 3 plus 5, gives me 8. And then I'm going to simply add the two together, which in the end would give me 10 for my final answer. So because I had a number in my problem, I'm going to have a number answer. All right, let's try our next one. I'm going to take f, which is my x squared. Oh, but instead of x, it asks me to use -3. So we're going to take -3 squared plus 1. And we're going to subtract g, which is 3 times -3 plus 5. Okay, so again, I'm plugging in that value for every x. So I'm going to simplify my first set of parentheses. -3 squared is 9. 9 plus 1 is 10. -3 times 3 is going to be -9 plus 5 is going to give me -4. So then I'm going to combine those together. So I'm going to make that into a plus because we've got minus and negative. So my final answer would be 14. Right? Almost done here. Let's look at the next one. I'm now going to multiply. So I'm going to take my f function, and I'm going to plug in a 5 this time. So I'm going to have 5 squared plus 1. Multiply it by 3 times 5 plus 5. Looking at that first set of parentheses, 5 squared is 25 plus 1 is 26. Looking at my next one, I've got 3 times 5, which is 15, plus 5, which is 20. So 26 times 20 is going to give me 520, right? Okay, we got one more here. So I'm going to take f, which is x squared plus 1, but now I'm going to substitute in a 0. So I'm going to say 0 squared plus 1 over 3 times 0 plus 5. Now I'm going to simplify. I'm going to have 1 over 5. That cannot be reduced, so that would be my final answer. So now we should be able to combine different functions, and the ways we can combine them is by adding, subtracting, multiplying, and dividing those functions.